Hello everyone, and welcome to today's chem lesson. Today we're going to wrap up our discussion on nuclear chemistry by talking about the two biggest nuclear reactions, two biggest types of nuclear reactions. Not decay, but reactions. And those are fission and fusion. Fission is when an atom splits or is forced to split into two or more pieces, and it releases large amounts of energy. The atomic bombs, the nuclear reactors, nuclear power plants, those are all fission reactions. Right? The difference between the atomic bomb and the nuclear power plants that we've created is that the atomic bomb, the fission bomb, is a uncontrolled chain reaction. Now, what does that look like? When we have uranium-235, and we hit it with a neutron, it causes that atom to split, to break apart into multiple pieces, and give off 3 more neutrons. Those 3 neutrons then loop back around and hit 3 more uraniums, causing those 3 to break down and release 9 more neutrons. And then those 9 neutrons loop back around and they hit 9 more uraniums, and they cause this to happen again, giving off 27 more neutrons, which then loop back around and hit 27 more uraniums, giving off another set of neutrons. Right? Uncontrolled chain reaction. Right? The more it happens, the more fuel it gets to then power itself more, right? It loops and it loops and it loops and it loops and it loops. In a nuclear power plant, that same reaction happens, but we actually capture these neutrons. We take the energy that gets released and we feed it to, power plants and whatever else needs to be given energy. But the neutrons that are here, we don't just let them go out of control. They capture some of these neutrons and then we feed them back in one at a time, as needed to create energy. There's multiple fission power plants around the world, right, that are running, producing this energy using nuclear reactions. Right? Atomic bombs are fission bombs that use uranium and a neutron to break down that nucleus, split that nucleus in half, release all that energy, and then feed into itself over and over again, releasing more and more and more energy. On the other hand, right, there's 2. Fission is about breaking something into pieces. Fusion is about combining little things together. And when you smash these 2 little pieces together, it releases a bunch of energy and creates a new substance. Right? Fusion has become the new chase, right? We're trying to figure out how to get fusion to happen on Earth instead of just where it does happen right now, which is on the stars. The sun is a fusion reactor. Right? The sun combines these small nuclei together to make a bigger one. Then it takes 2 heliums and it combines those together to make a bigger one. And it keeps going, taking those little nuclei and smashing them together, releasing a bunch of energy to make bigger things. Right? When we look at the death of a star, right? When a star runs out of energy, it's because it has made things that are too big to smash together. There's not enough energy in the star left to smush together 2 irons. Right? Or if there is, the energy that comes out is not enough to then do it again. right? Just like fission, fusion is a reaction that feeds itself, right? The energy that is required to smash these two pieces together is less than the energy that is released once they are combined. And so then it feeds back in. The energy released from fusing together these two hydrogens to make that helium can then be used to fuse two more hydrogens together to make another helium, or two heliums together to make a lithium, a boron, the next thing up, right? Or a helium and a hydrogen together to make a lithium. Beryllium is two heliums together, right? As you put these pieces together, you can combine and make them bigger and bigger and bigger and bigger and bigger. But the bigger they get, the less energy is released when they are made, which then leads to the star running out of energy. When we figure out fusion, when we figure out cold fusion, fusion that doesn't require an insanely high temperature or an insanely high pressure, we will be able to create much, much more energy, much, much more clean energy as well. Ideally. We'll see what happens. That's really it. Fission is about taking an atom and breaking it apart, releasing energy. Fusion is about taking two atoms and fusing them together, smashing them together to release even more energy than fission. Right? Fusion releases more energy by combining things. Fission releases a lot of energy, just not as much as fusion, by breaking a big atom into pieces. And that's really all there is to say about it at our level, right? If you go on and you study more chem in the future, you'll talk more about fission, more about fusion. But now, that's it. We're done. And so I'm going to wish you all a fantastic